All right, welcome everybody. Today we're going to talk about lesson number 65. This is about finding exact values with triangles and then more formulas. So when I say more formulas, it's the last 8 formulas from the formula sheet that we haven't yet used. So I'm going to show you that you can use them to find the same kinds of problems and things that we've been doing so far. So take a look here. You are given 2 pieces of information, one about u and one about v. So you are told that the cosine of u is equal to 15 over 17, and that lives in quadrant 1. Then you are told something about v, which is that the sine of v is equal to negative 3/5, and that lives in quadrant 3. You're going to be asked to find the following 4 things. And in my opinion, it's always good to start off by kind of drawing each of the triangles and then giving yourself a little reference key that you can then use to calculate anything, and these 4 things in particular. So I'm going to go over here on the left. This is going to be all my u information. And then over here on the right is going to be all my v information. And I'm going to color code that for you throughout. Hopefully that'll make things nice and simple. So if we're talking about u and we're talking about a triangle in the first quadrant, again, you got to think back to chapter 4. You can only draw it like the bow tie. Your u is the angle at the origin. A cosine is an adjacent over a hypotenuse, or it's an x over an r, however you want to think about it. So this is 15, this is 17. In order to find the third side, you would use the Pythagorean theorem, or you would recognize this as a Pythagorean triple and realize that the third side is 8. However you find that third side doesn't matter as long as you can. Remember that in quadrant 1, we really like quadrant 1 because everything is positive. So what I'm going to do is I'm now going to find the sine of u, the cosine of u, and the tangent of u. The whole idea is that if you find them once, you can then use them to solve the rest of the problems, and you don't have to go back and recalculate it every time. So the cosine of u obviously was given, but I just like to rewrite it all in a row here. So the sine is the opposite over the hypotenuse, which would be 8 over 17. And then your tangent would be your opposite over your adjacent, which would be 8 over 15. And what I officially have here is all of my u information. So for anything in the upcoming problems that ask you about u, you have to use this triangle and then this sine, this cosine, and this tangent. We're now also going to draw a V triangle. Notice that here it tells us that the V triangle is in quadrant 3. So again, you have to draw it like the bow tie. The angle V has to be at the origin. A sine is an opposite over a hypotenuse, so I know that it's 3 and I know that it's 5. And then remember, the negative has to go with the 3 because the hypotenuse or the radius is always positive. Probably it's pretty easy for you to recognize this is a 3, 4, 5 triangle, and then specifically it's a negative 4 because of the fact that you're in the third quadrant. And then again, just like the previous example, we're going to go here and make ourselves a little key for all the V information. So the sine of V they gave me was negative 3/5. I'm now going to find the cosine of V, which would be negative 4/5. And then the tangent of V is equal to the opposite over the adjacent, which a negative over a negative is going to turn into a positive. Again, I personally recommend that you do this whenever you're talking about a triangle problem. Go ahead and find all the U information, all the V information, and you're going to see why in a second. It'll just be so handy that you did that all at once. So here in number 1, they are asking me to find the cosine of u plus v. This is why we have a u triangle and a v triangle. So we have all the information that we need. If you were to go ahead and pull up your formula sheet, this is equal to the cosine of u times the cosine of v minus the sine of u times the sine of v. Remember, you do not have to memorize those formulas. I would rather you take an extra 15 seconds to make sure you're using the right formula as opposed to running the risk of getting it incorrect. And now all you're going to do is use the values that you found up top, and you're going to insert each value into the appropriate spot. So the cosine of u is in orange, and that is 15 over 17. The cosine of v is in green, and that would be negative 4/5. Minus the sine of u is in orange, that's 8 over 17, and the sine of v is green, that's negative 3/5. Notice how the denominators in each case is 5 times 17. That's good. That should always be the case. So if you go ahead and multiply the first fraction, 17 times 5 on the bottom, that's 85. Negative 4 times 15, that is negative 60. Minus In the numerator, 8 times negative 3 is negative 24. 17 times 5 is still 85. Notice that you have minus a negative, so of course that turns into an addition. So negative 60 plus 24 is negative 36 all over 85. If you could reduce that fraction, you certainly would, but you can't, so you're done. And these problems, they always wind up having fractional answers and also oftentimes with radicals. I actually chose a very easy example here where they were both Pythagorean triples, but perhaps in the homework and in the future, you're going to have some value that has a radical. Shouldn't make that big of a difference. Take a few extra seconds just to double check, but the idea is certainly the same. I don't want it to get lost here. I know it's a little small, but I have for you here, what if I was to ask you now for the secant of u plus v? You don't have to do any additional work because the relationship between a cosine and a secant is the same, whether it's of a single thing or of a sum or difference. So notice the problem started with the cosine of u plus v. Because this is asking you for the secant of the same quantity, the reciprocal relationship still applies, which means you can take your answer, negative 36 over 85, and you can just flip it to be negative 85 over 36. So again, I just wanted to point that out going forward. The reciprocal relationships still hold, so no need to repeat the process. There is no secant of u plus v formula anyway, so you have to find the cosine and then do the reciprocal, but please just make sure you know that it is a thing. Here in number 2, we're now doing the tangent of v minus u. So order does matter. If the v is first, you have to put the v first. You don't get to make up your own rules. So looking at the formula, it's the tangent of the first thing minus the tangent of the second thing, all over 1 plus the tangent of the first thing times the tangent of the second thing. You're going to go ahead and plug all the values in where they go. So there is my big fraction bar. The tangent of v, that's in green, and that is going to be 3 over 4. Minus the tangent of u is in orange, and that is 8 over 15. Then 1 plus 3/4 times 8/15. And again, here's still my big fraction bar. So up on the top, I'm going to find a common denominator. The common denominator of 4 and 15 would be 60. So 3 times 15 gives you 45 minus 15 times 4. So 8 times 4 is 32. Then in the bottom, this is 1 plus 24 over 60. I'm going to rewrite this one as a 60 over 60 just to find a common denominator. So in the top, 45 minus 32 is 13 over 60. On the bottom, 60 plus 24 is 84 over 60. More often than not, you're going to wind up getting the same denominator in the top and the bottom. So either by doing the keep, change, flip, or you kind of just know they're going to cancel, you're going to get a final answer of 13/84. And just so you know, there really is no easy way to know ahead of time, is it going to be positive? Is it going to be negative? You're better off just doing the work and then seeing what happens. So now notice that for these final three, or for number 3 and 4, you're only being asked to find something involving a single variable. So make sure all the u information, you're using the triangle on the left. Make sure for all the v information, you're using the triangle over on the right. So the first thing they're asking me for here is they are asking me for the sine of 2u. So again, if you go ahead and look up the formula, you're going to get 2 times the sine of u times the cosine of u. And again, this is the u triangle. So make sure you're only using this orange information. So you're going to go ahead and sub in that sine and that cosine. So this is going to be equal to 2 times the sine of u is equal to 8 over 17. The cosine of u was equal to 15 over 17. Make sure you remember when you're multiplying, technically that's 2 over 1. So you'd multiply all the numerators, which would be 2 times 8 is 16 times 15 is 240. And then 1 times 17 is 289. Again, I don't want you to turn that into a decimal. If you could reduce that fraction, I would like you to do that, but you can't, so you're done. Finally, the cosine of v over 2. So again, please notice that this is a v situation. So we're going to be using all of the v information from the top right-hand side. A little bit of extra work here because it's the half angle formula. Whenever there's the half angle formula, remember you have to decide plus or minus. So just looking up the formula, this is plus or minus the square root of 1 plus the cosine of v all over 2. Let me just check that formula real quick, make sure it is, in fact, the positive case. Okay, right here, good. So plus or minus 1 plus the cosine of u all over 2. Looks good. So now from here, in order to determine the plus or the minus, you have to do a little bit of detective work. So if you go back up and look at the V triangle, notice that the V triangle was in quadrant 3. So what that tells me is that because the V triangle was in quadrant 3, that tells me that V has to be between pi and 3 pi over 2. And again, if you look at quadrant 3, those are the two quadrantals for which V is between. This problem, when you're doing V over 2, this is no longer asking about V, this is asking about V over 2. So if you take V and divide it by 2, you have to divide each of the bounds by 2. So this pi becomes pi over 2, and this 3 pi over 2 becomes 3 pi over 4. So now that you have your V over 2 information, if you're talking about V over 2 being between pi over 2 and 3 pi over 4, here is pi over 2, here is 3 pi over 4. So if you know that V over 2 has to be between those two, then you know that V over 2 has to be in quadrant 2. Are cosines in quadrant 2 positive or negative? They are negative, which is why I'm going to select the negative version. So as I move to my next step, I'm going to select the negative, again, because V over 2 has to be in quadrant 2. Then I'm going to go ahead and substitute in. So 1 plus the cosine of V. Again, if you go up top, you're going to see the value is negative 4/5 all over 2. Go ahead and find a common denominator just in the top. So in the top, you're going to have it over 5. So that's going to be 5 minus 4 over 5, and then all still divided by 2. This is then going to become 5 minus 4 is 1. If you take this 2 over 1 on the bottom and multiply by the reciprocal, you're going to wind up with 1 over 10. So you now have the negative square root of 1 over 10. That becomes negative root 1 over root 10, which you will rationalize to be negative radical 10 over 10, and that is, in fact, your final answer. The fact that it's negative, great, doesn't matter either way. The fact that it has a radical, that happens a lot. Just make sure that you rationalize your denominators as always. So if I want you to use a triangle like we did here for this page, I will tell you. So again, you normally will have two quantities, or sometimes you'll just have one, but you're going to go ahead and draw your triangles. I think it's best to make yourself that little key and then go ahead and evaluate from there. All right, so the second half of today's lesson has to do with the remaining Chapter 5 formulas. There are two sets, the product to sum formulas and the sum to product formulas. Now, these are used very specifically for a reason in calculus to find something called an integral. Because they have a very specific purpose in calculus, I would be weary of using these unless the problem specifically tells you to. While there are other cases that they do work, sometimes they can make the problem harder than you mean it to. So again, I would only use these when the problem specifically calls for it. So I copied the formulas here again off of the formula sheet just so I didn't have to keep going back and forth. And you can see that from the product to sum, what it actually does is it takes a multiplication, which is a product, and it turns it into a sum or a difference. And then obviously you can also go in reverse where you start as a sum and instead turn it into a product. So again, very particular uses for these formulas. But the truth is we can go ahead and do all of the things that we've done so far with all the other formulas. We can now do them for these. these. So let's go ahead and take a look at number 5. So here in number 5, it asks you to rewrite the product of cos 5x sine 4x as a sum or difference. So again, rewriting is something that we have done. That means taking one side of the formula and writing it as the other side. Here we have the product of cosine times the sine. So if you look at your options here, you'd be choosing the one that is the cosine times the sine, which is the 4th version right here. And they're telling you to rewrite it as a sum or difference, which again is how you know that you're going to use this product to sum formula. So taking a look at the highlighted orange formulas here, you're going to start by identifying u and v. So as always, we're going to go ahead and have u be the first quantity and then have v be the second quantity. And in these cases, we're talking about 5x and 4x. The cosine times the sine is just what tells us to use that orange formula. So if we go ahead and use the formula, we're going to start off with a 1/2. Then it's the sine of u plus v, which would be 5x plus 4x, minus the sine of u minus v, which would be 5x minus 4x. So again, just like always, you're just plugging the values in where they belong. Then you're going to leave the 1/2. You're going to simplify this as the sine of 9x minus the sine of x. And for our purposes, this is as far as I'm actually going to ask you to go. So this is your answer, 1/2 the sine of 9x minus the sine of x. Now, again, you might be thinking to yourself, well, what does that actually do for you? Why do I care about that? Again, for now, I just am introducing it to you, making sure you understand that it can take a product and turn it into a sum or difference. Again, there's a lot more you'll see with it next year, but for now, you're just kind of getting used to, the bare basics. So then number 6 is a similar question here. You are being asked to rewrite the product of a sine times a cos as a sum or difference. So again, looking at the formulas, you have to make sure that you select the correct one. So in this case, you're talking about the sine times the cos. And again, your u is going to be the first quantity and your v is going to be the second quantity. So if we go ahead and use that purple formula, we're going to go ahead and start off with a 1/2. And then it's the sine of u plus v, so 5x plus 3x, plus the sine of u minus v, which would be 5x minus 3x. Go ahead and simplify. You're going to get 1/2, and then the sine of 8x plus the sine of 2x. And again, the sine of 2x is a formula, but because all it wanted me to do was write it as a sum or difference, that really is going to be good enough. So if you think back to when we kind of started section 5.4, the first thing I had you do was some formula manipulation, which is what this is. You might just want to write yourself a tiny little note here. Just for some of the homework problems tonight, there's kind of an interesting thing. Let's say you wound up getting the sign of something that was negative. Based on the even and odd formulas, haven't used those for a while, but because of the even and odd formulas, the sign of negative u is not considered to be as good of an answer as the negative sign of u. That's true based on the fact that the sine function is odd. And then similarly, if you were to get the cosine of negative u, because the cosine function is even, the cosine of negative u would actually be equal to the cosine of positive u because that function is even. So again, even is because they wind up being the same, and odd is because they wind up being opposite. So this is just for your final answer. If you wind up with a negative inside of the sine or cosine, generally the answer will want you to apply the even and odd formula. So I didn't happen to put one of those on here, but you might just want to make a note for future problems. So that was the first thing, formula manipulation. And now we're going to use the sum to product formulas. And we're going to go ahead and start by finding an exact value. So we have done exact values up to this point. So we're going to go ahead and do one in this case here. So when you're trying to find the exact value, you have to make sure you have the correct formula. So this is the cosine of something plus the cosine of something. So you have to make sure that you're selecting this formula right here. You're going to go ahead and identify u as being the first value and v as being the second value. So if you use the formula, it's 2 times the cosine of u plus v all over 2. And then that's multiplied the cosine of 195 minus 105 over 2. So 2 times the cosine. So 195 plus 105, that gives me 300 over 2. And then 195 minus 105 gives me the cosine of 90 over 2. So this is 2 times the cosine of 150 times the cosine of 45. And then hopefully you remember, it hasn't been so long, you actually know the cosine of 150 and the cosine of 45. And by me saying you know them, it means you can easily just look them up on your unit circle. So if you go to the cosine of 150, you will of course be in the second quadrant, and you will get a value of negative radical 3 over 2. The cosine of 45 is safely in the first quadrant, and the x value is positive root 2 over 2. To go ahead and finish this problem, you literally just want to multiply all of the numerators and all of the denominators. So a negative radical 3 times a radical 2 is a negative radical 6. Well, actually, even before we do that, we can reduce. So you can reduce this 2 with this 2. So then if you multiply what's left, you're going to get a negative radical 6 over 2. Remember, the whole point of something that asks you to find an exact value means you want to give your answer as an exact radical, no decimals allowed. So that's a way that you can do it using a sum to product formula. In addition to finding exact values, we also have used all these equations to prove things. So we're going to do a little proof here on the right-hand side. You're going to prove that those two sides are equal. And again, hopefully it would make sense that you're going to start on the left-hand side, since there are certainly a lot more things to choose from. You, again, have to make sure that you're using the correct formulas. So in the denominator, the cosine of t plus the cosine of 3t, that's the green formula that we already did. Then you have to use the formula that adds the signs. So that's going to be my orange formula here. I'm going to go ahead and start plugging in. And again, your u is going to be the first value, and your v is going to be the second value. So based on the formula here, I'm going to go ahead and start with 2 times the sine of t plus 3t over 2 times the cosine of t minus 3t over 2. And again, that's using the orange formula. Over, now I'm doing cosine plus cosine, so that's 2 times the cosine of t plus 3t over 2 times the cosine of t minus 3t over 2. And then from here, without even calculating certain things, I can see that some of the things are canceling. So I can cancel these 2's. I can cancel the cosine of t minus 3t over 2 with itself, because there's one on the top and one on the bottom. If I calculate the numerator, I'm going to get the sine of 4t divided by 2, which is the sine of 2t. On the bottom, I'm going to get the cosine of 2t. And again, keep your eye on the prize. Your prize here is the tangent of 2t. All along, I've been trying to stress to you that those easier relationships from the beginning of the formula sheet, like the reciprocal and the quotient, those are true as long as the variables match. So because of the fact that both of these are a value of 2t, a sine over a cosine is, of course, a tangent. A tangent of what? A tangent of 2t. Because this was a proof, you've proved it. Left-hand side is equal to the right-hand side. Again, whole point of this backside here is to show you that everything you've done so far for all the other formulas, you can continue to do here for the last batch. And finally here, you're going to go ahead and solve the sine of 5x plus the sine of 3x is equal to 0. And they're asking you to do so with the general solution. So the last piece of the puzzle is to go ahead and solve an equation. So here, as we go to solve this equation, hopefully you would realize that the sine of something plus the sine of something, you can go ahead and convert that to a product. And the reason why that would be good is because you can then use the zero product property. So again, u to start and v to finish. You have to make sure you're selecting the right formula. So it's 2 times the sine of the two things being added divided by 2 times the cosine of the two values being subtracted over 2 and equals 0. Then you're going to go ahead and simplify. So 2 times the sign. So 8x divided by 2 is 4x. Then you have the cosine of 2x divided by 2, which is x, is equal to 0. And then that actually is really helpful. The fact that this is now a multiplication means that I can actually divide both sides by 2, which means the 2 just cancels, which means I can now set each quantity equal to 0 and solve. So sine of 4x equals 0, cos of x equals 0, and I'm going to go ahead and solve each one. But actually do the easier one first. So the cosine of x equaling 0. Again, if you think about your unit circle, the cosine is the x value. So that's true at the top and at the bottom. Because they're asking you for the general solution, you would say pi over 2 plus pi n. That would give you everybody from the top and the bottom. Then over here, the sine of 4x, this is one of those multiple angles. So remember, when you're solving a problem like this, you're going to go ahead and start assuming that you're just solving the sine of x equals 0. So if I think about my unit circle, again, the sine of x is equal to 0 at 0, pi, 2 pi. The easiest way to say that is by saying pi n. And again, instead of saying x equals, you're going to say 4x equals. And then in order to get that final answer, you would have to divide by 4. So you can say that x equals pi over 4n. And these two pieces together, are going to go ahead and give you your total solution here. So again, these are formulas which you are now allowed to use. I would strongly advise you only use them when it specifically says use these formulas. Otherwise, it can create some headaches sometimes. So thanks very much for tuning in, guys, and we will catch you next time.